Let us discuss an 8086 program to count the number of even numbers stored in a block of bytes. Let the block size equal to n, and we are expecting the result in DL register. Now let us declare the data segment. My data segment n, the number of bytes defined by db. Then let us let be 10. Then the block name A, that is our array, defined by first value is some 23, 34, 50, some 55, 34, 21, 77, 89, 70. Let's count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, even numbers 1, 2, 3. Okay, this is the end of my data segment. ENDS, ends, end of the segment. Then code segment starts. My code segment assume cs colon my code command ds colon my data start move x comma my data move ds comma x. Now the data segment is ds register is initialized. Then we are expecting the result in DL register. So let us initialize it. Move DL comma 0 0. Now it is initialized. Then we need an index variable for the block. We have two index registers SI and DI. Let us use SI here. Okay, so let us point SI to our block. So move SI comma offset. Now you know what is offset. It is nothing but the displacement to the data from the beginning of the block. Offset of A. Let us take the first data to BL. Move BL comma content of the location pointed by SI. Now our first data is in BL. We want to check whether it is even or not. You can do it by dividing the data by 2. If remainder is there, it is odd. If remainder is 0, it is even. But it is not the microprocessor way. In assembly language programs, we will shift the LSB to the carry flag. If carry flag is set, the data is odd. If the carry flag is reset, the data is even. You know, for every even number, LSB is 0. For every odd number, LSB is 1. So this feature is used in assembly language program. For that, we are using rotate right instruction to move the LSB to carry flag. This instruction will shift all bits to right and LSB will be moved to the carry flag and the same LSB is moved to the vacant MSB. So ROR comma. Let us see the working of ROR instruction in detail. There are 8 shift and rotate instructions in 8086. ROR is one among them. It rotates the required number of bits in the register to the right side one by one, such that the rightmost bit that is being rotated is again stored as the MSB in the register, and that bit also stored in the carry flag. If you specify a number of bits equal to 1, then the rightmost bit, the LSB, will be stored in carry flag as well as in the MSB. Rotate right instruction, move DL comma C0H 0 C0H, then ROR DL comma 1, that you rotate one bit right. C0H is 1100 0000, this is C0, one bit rotating right, so this bit will move to CF and the same bit will be moved to the MSB. So if this is rotated to the right to the carry, this will become 0 and this previous bit will come here, this previous bit will come there, then 0 will come there, then at this position will be filled with this bit, so it is 0, this position is filled with the previous one, this position is filled with the previous bit in the previous position, then this will be filled with the previous one, and MSB will be filled with the previous LSB. This one, that is whatever move to CF, it will come in this bit also. So you are getting 0110, that is 6, and you are getting 0, so 60. Okay, let us try the program. Move DL comma C0H or DL comma 1, we are expecting 60 in DL. See DL part, it is 60. Now move DL comma C2H. C2 means 1 1 0 0. 2 is 0 0 1 0. Then shifting 2 bits right, shifting 1 bit right. First the 0 will reach carry, then this portion will be filled the previous one, 0 0, and this portion is filled with this 0 0, this will be filled with the previous 0, then previous bit, it is 1, and this will be filled with the previous bit, the 0 will come here. Now it is shifted 1 bit, then shifting the next bit, this one will reach the carry, then here 0 0 0 0, this is filled with 1, this is filled with 1, this is filled with 1, sorry, that is filled with 0, and this MSB is filled with this bit, the same bit with 1. So it is 1011, it is B and it is 0. Let us see the code. DL is move DL commas C2, move CL comma 02, then ROR. So what you are getting in DL, you are getting B0. Okay, we are getting the same B0. So in this way, this ROR instruction works. Okay, if the data is odd number, no need to increment DL. We should go for the next data. Okay, so we'll be using jump on carry, not even. Otherwise, we should increment the count of even numbers and go for the next data. That means we should increment SI register to point to the next data. So INC SI. Go for the next data. So how many times we should take data? So we need the loop instruction for the next data. Here we are taking the data to BL register. Next our label. So we are using loop instruction. So we should prepare CX register for that. So move CH comma 00, because our data is only 8 bits. Move CL comma N. Now CX register contains the count of elements in the block. Then where the position of this label not even? If not even, we will never increment DL. Just go for the next item. So not even, its position is here. Take the next data. Once we are out of this loop, our DL register will contain the number of even numbers in this block. Then let us go to terminate the program. AH is the function number. AL should contain the return value. Then we will be invoking the DOS interrupt Q1H. It's the end of the code segment, and there's the physical end of the program, and this is the label of the first executable instruction. Turbo debugger. The program is open in Turbo debugger. Let us start the trace. DL is initialized. SI points to the block. Cx carries the number of elements 0, 0, 0, A. Then we are taking the first data. We know the first data is 23. Its hexadecimal is 17. So BL register is now 00. Now it is told 17. Okay, we have taken the first data. It is an odd number. We are doing the rotate right. Now the carry flag is 0. After doing this rotation, carry flag will be set. Okay, it is set now. It is jumping, jump on carry, or didn't increment DL. It is going to take the next data. So I can see SI loop instruction. We are taking the next data. It is 34. It is 22H. Okay, we are rotating it. Carry flag will be reset. Okay, we are incrementing DL. Then going for the next data. Then loop instruction. We are taking the next item. It is 50. So it is 32H. Okay, so we are doing ROR. Carry is reset. Increment DL. Going for the next data. Okay, we are processing all the data. CX is 2 now. CX is 1 now. CX is 0. So it is going to terminate the program. DX registers, it is 0004. That is DL carries 04. That means there are 4 even numbers, 1, 2, 3 and 4. Okay, our answer is correct.